Maybe I should go back and review a little bit before moving on. For these two, plus you guys have to go back and do the even, so might as well, right? You guys remember what shape this graph took?
Nope.
I don't know how you describe it, but it looks like
It's
this.
like a slide.
Curves. Kind of like that. So it gets closer and closer to the y-axis but never touches. What did we call that line that it never touches?
Asymptote.
Yeah. This is called a vertical asymptote. The equation for this green line, this vertical asymptote, is x equals 0. Vertical lines always have an equation of x equals something because all the x values on this line are 0. If I move the line over a little bit, I don't know if I can grab it or not. No. It might be at x equals 1, x equals 2, x equals -1. Anyway, there's also in this picture a horizontal line that the graph approaches but never touches. That is called a horizontal asymptote. That's what it looks like. That's what I'm trying to say. That's an S. The equation for this horizontal asymptote is y equals 0. So if it moved up 1, the equation for the asymptote would be y equals 1. If it moves down 1, y equals -1. So anyway, all these graphs today are going to look something like that. They have those two asymptotes. Okay, let's play a little game here. What do you think this is going to do to my graph?
Move it up 2.
Up 2, which means the vertical or the horizontal asymptote would become y equals 2. So basically this number out here is the same thing as that number right there for the horizontal asymptote. You guys remember how we moved it left and right?
Put it around the x.
Yeah. That moves it, how's that move it? Right 1. Moves the whole graph right 1, which means the vertical asymptote would be at x equals 1. So it's kind of the opposite of, remember how when you put it directly on the x, it moves it the opposite direction. So this moves it right 1. So basically, whatever x value makes the denominator 0 is going to be the vertical asymptote. Because it can't equal this, so there's going to be nothing happening at x equals 1. Like there's a line right there, boom, nothing's happening there. Okay, because it makes the denominator 0, that's a no-no, that's why it's a vertical asymptote. Nothing's happening on the graph at x equals 1. Okay, there were a couple of, those were the two main things, but there were a couple other things. You guys know what happens if I do like a 4 right there?
It goes up steeper.
It just, picture's same, it just, yeah, it goes up faster, it's just, anyway, not much. What if I put a negative right there?
Makes it,
Or, actually the negative could be here or something. It just flips it vertically, so like this guy will be down here and this guy will be up there. So, they don't really ask about that stuff though, they just asked about the horizontal vertical asymptote. Alright, now let's do 17. Let's remember how we graphed it. No, you need to go to graph paper. Yoink. And then we zoom out. All I want to do. And then go not very good vertical line. Pro horizontal. Okay. No. Okay. All right. So on number 17, how's this graph going to move? Left 2. So you don't really need, so it's all over here. We don't really need to draw in the asymptotes, but just know that it's going to be right there. We did move up or down, so the horizontal asymptote is going to be the same. You don't have to draw that part, but just to give you an idea. Okay, so what we did was I made them choose, we can't choose x equals -2, right? That's where nothing's happening, right there. So we chose numbers. The first step we chose was a step away. Here, let me do it like this. -2, nothing's happening. So I'll just leave it blank. I chose a half step away, and then I went -3, -4. Went back to integers. And then I went the other direction. What's a half step away from -2 in this direction? -1.5. Which means I also am going to use -1 and 0. So those are the 6 we chose. Chose x values that are close, the closest to the vertical asymptote. And then we plug stuff in and then we graphed it. That's basically it. Okay, plugging in -2 doesn't work. I didn't really need to put that. -2.5, that would be -1/2. 2 divided by -1/2 is -4. Just gonna have to take my word for it. -3 plus 2 is -1. 2 divided by -1 is -2. -4 plus 2 is -2. 2 divided by -2 is -1. You can do this on the calculator. -1/2 plus 2 is 1/2. 2 divided by 1/2 is 4. -1 plus 2 is 1. 2 divided by 1 is 2. 0 plus 2 is 2. 2 divided by 2 is 1. And then we graph. Let's go a different color so it shows up better.
Brown.
No.
Wow.
Yes. It was a racist. Negative. I did a racist. -2.5, -4. Okay, that would be -2.5, -4 right there. -3, -2. And -4, -1. Oh man, nailed it, kind of. And so close. And then on the other side, we got -1.5, 4. -1, 2, 0, 1. Basically what graphs look like when there's an x in the denominator, not the numerator. The book called these reciprocal functions because the reciprocal of x is 1/x. Alright. Now, try those evens. Good luck. Let's be.